so welcome back to the randomized complete block design. That is RCBD. Alright, so when we talk of it is a design in which K treatments are compared. Don't forget about the word compare. In the CRBD, we do what? We assign the treatment. But here, what we do is that treatments are being what? Compared. Within each of the what? The blocks. Each block contains K matched experimental what? Units. And the K treatments are randomly what? Assigned. One to each of the what? The units within the what? The block. So in this treatment, know that treatments are what? Assigned. So when you know that the treatments are assigned, when a person is given to you and you don't know the type of design to go about it, you will know how you can what? Go about it. So let's see if you can get one question. Alright, so we have a question on our board and we are going to use an alpha level of 0.01 to conduct an ANOVA and interpret their results. Alright, so in the question you hear the word samples are and the treatment are being what? Compared. That will let you know that it is talking of what? Block design. Alright, so let's see how we are going to go about it. So in this table, we have to write the table. We have to come out with we know our B1, B2, B3, B4, but that one is being comparing to what? Some what? Variables. That is from A to what? From A to F. From A to F that you see here is representing something. Okay? Alright. So we have seen how it's being compared. So let's see how we are going to rewrite the table. Okay. Alright, now in case I clean it, I may not get anything to explain for you to understand. So I'm going to manage this side. I will clean everything and draw it big for you to see. But this is the idea. So when you come to B1, that is under the B1. How we can see that? So under the B1, you see that we can have A to what? F. A, B, C, D, E, F. So that's what is going to represent our row. Alright, so the A is what? 34.4. So here is 34.4. Then the B is what? 33.1. 33.3. 33. The B is 33.4. 33.4. And the C is what? 34.4. 34.4. And we have the D to be. So you guys focus on the B side here. And we have the D to be 36.8. 36.8. Then the E. We have the E to be 36.3. 36.3. We have the F to be 36.4. 36.4. So that's how we are going to arrange it. Lovely. I hope you can see it. Alright, so when you come to the B2, we also have it to be. So start from the A. Do you have A in there? A? No, something is wrong somewhere. Let's check. Let me check. Alright, so this one is the A. We have F, D, C, E, A, B. Alright, so the F is appearing 2 times. Good, so let's continue. It's not in you. Alright, so the A is what? 35.9. Then still focus here. The B is 31.9. 31.9. The C is 34.0. The D is 36.6. The E is 34.6. The F is 37.6. Sorry, 37.3. Now let's come to the B3. So when you come, you check. The A is what? 36.0. The B is, I'm lost. Alright, the B is 34.9. The C is 34.5. The D is 37.0. The E is 35.9. So simple, what we can see that. The F is 37.7. Let's come to the B4. So now, the B4, the A is what? 34.1. The B, 37.1. The C, 33.1. The D, 36.4. The E, 39.1. The F, 36.7. Beautiful. So there are some questions that this will not be given to you, but they can give you only this to perform a block design. That one is there. So getting the two will not confuse you now. Now, after getting this, the next thing to do is to sum all the rows and all the... Okay, so you sum all the rows, then you sum all the C's. That is the column. Alright, so that's what we are going to do now. So because of space, I'll be back. Alright, so as I said, because of the space, you add all the rows here and all of this side. Now, remember that in the RCBD, that is the block design, your treatment is going to be on the C, right? Okay. Remember that in the RCBD, your treatment is going to be the row. Your treatment is going to be the what? The row. So here is going to be what? Treatment. So these are the treatment you are going to compare to what? The block. So this is going to be the treatment. Don't forget it, nobody will tell you. And this is going to be the block. Alright, so we have a treatment and we have the what? The block. So this is going to be the treatment. This is going to be, let's say, a response to what? The treatment. That's what we did here. And you sum everything here. You sum here to this. And when you sum, you get this. So bring this table here. Okay? So when you sum the whole of this, you get this. Sum the whole of this, you get this. Sum the whole of this, you get this. Sum the whole of this, you get that. Like that. Then the same way to this, and that's what you're going to get here. Now, the total of this, that. When you total everything here, it's going to be the same as the total here. If your total here is not the same as the one here, it means you are wrong. So this is what you are going to get for that. The block. And you know that the treatment is what is on the row and the block is what is on the other side. Alright. So, and you know that the row is the I and the other side too is the what? Is the J. Don't forget that. So the row is now going to be our K. The one which is representing the A, B, C, D up to F is the K, which is 6. And the other one is what? 4. Alright, so looking at the treatment, that means that we are going to get, that means that the treatment is 6. So we are going to get mu1, mu2, mu3 up to mu1, 6. You have to be careful with that. And also for the block, since the block is 4, that means that because we have our table to be like this. This is the block and this is the treatment. So you state, since you have used mu here, you can't use it again. So use alpha 1, alpha 2, alpha 3, alpha 4. Don't end with 6. Alright, so the alternate hypothesis is going to be the same. At least 2 of the means are different. At least 2 of the means are what? So here, at least 2 of the means are different. So here will be at least 2 of the alphas are what? Different. Alright, so go to the grand total. The grand total is the summation of this side, that side. So what you get, you square it. That becomes the grand total square. Alright, so now you go for sum of square treatment. We are going to find the sum of square treatment and the sum of square of the what? Of the block. So the sum of square treatment is what is represented by what? K. And that is the I, as what I told you. Alright. And now this is the formula, and achieving it is easy. See, if you are going for sum of square treatment, which is the K, then you divide it by its opposite. You don't divide it by K again, but you divide it by its opposite, and that is what? R. So the T square means that the summation of the what? Of the T's. Don't forget that. So the summation of the T's is not like you sum all, then you square it. No, it's the square of it. After squaring it, then you what? You sum them up. That's how we are going to do it. And you are using it to do that of the what? Of the row. The one on the row side. So the one that we total it here. The total here. The one that we total here. We total one here and one here. So the treatment is the row. So that is this side. So you use the values here, then you square each, and that's going to give you this. So that is for the treatment. So the block on will be here. When we get there, you will see it. Alright, let's move on. So that is that. So when you come to sum of square treatments, then it becomes this over what? The 4. I have told you already, sum of square treatment means is K. So you divide by R. Alright, so that's that. And that's that for that. So you get that to be 31.358. Alright, now let's look at sum of square of the block. So when you see the sum of square of the block, it's just simple. The block side is the R, right? That's why we have R. So you divide by its opposite, which is the K. That's why we are dividing by K here. Good. So here too will be J. And that's why we are using the J here. So this means that this is a block, right? So the total that we have here, you are going to square each of them, then we add it. And when you do that, that is what you are going to get. So, okay, let's continue. Alright, so you know this thing with a lot of calculator and all that. So now, sum of square the block, right, as I explained already. You are going to get this to be your what? Your final answer. Good. So back to, so now we are done with sum of square treatment, sum of square block. That's the thing. So you come to sum of square total. So you represent here by T0. So that it will not be the same as the R. That's the treatment. So this is sum of square total. So sum of square total, this is a formula that we use to do it. And what does all this means? All this means that on your table, pick each value and square it and add it. So if you pick this square, then you add them. And when you are done with all that, this is going to be your final results. Alright, so now we know the value here to be this. So then you bring your, alright, so with this, you divide this by that. We know this value already. Divide it and you get this. So you subtract. So this is going to be your results. Then we use the sum of square total, sum of square treatment, and sum of square of the block in order to get sum of square of the area. So that's the formula. Then we subtract there. So this is the sum of square of the area. Alright, so now we are now going to the mean square So we are not going to take the mean square treatment, the mean square what? Of the block. See you, and the mean square of the what? Of the error. So you know that we are going to get 3 here. See you. Alright, so now let's look at the mean square of the treatment, mean square of the block, and the mean square of the what? Of the error. So since here we are dealing with treatment and block, we are going to get the mean squares to be what? 3. And R is divided by each degree of what? Freedom. So we know the mean square of the treatment, the degree of freedom is what? K minus 1. That is that. So sum of square treatment over each degree of freedom, sum of square of the block over each degree of freedom, sum of square of the error. And the degree of freedom for the error combine the two. This and this. That. Alright. In some case, you can expand and simplify this and write it there, but that will be much for you. So now, divide that, you have these values already. So divide it, and you go your way. Alright? So this formula too, you don't need to cheat, like mean square of the treatment. So sum of square of the treatment over the mean square of the error. Because all of this is, over each what? Degree of what? Freedom. And you go your way like that. Alright, so when you come to the F calculator too, we will have to find that of the block and that of the what? Of the treatment. Or that of the treatment and that of the block. So F calculator for the block will be mean square of the block over the error. Alright? Over the error. So here that you are going to divide by the error. I hope you can see that. So F calculator for the block is mean square of the block over 8 what? Error. And F calculator for the treatment is mean square of the treatment over what? Mean square of the what? Of the error. And that's the value you are going to have. So here you have to state F particular. You have to state one for the treatment and one for the what? For the block. Because so for the treatment, you know that the treatment, the degree of freedom is K minus 1. So the K minus 1 will be here. Then here will become the combination, that is the error one. The error degree of freedom. And when you come to F calculators for the block 2, you see that the block is what? R minus what? 1. Or let me say R. So that R minus 1, then the 2 will come. That's how it is. It's not limited anymore. Alright, so you know how to read this on your book. So that's what you're going to have for that. Okay, so now see you for the decision and the conclusion and the ANOVA table. Alright, so now let's see that on the treatment. So we are combining the decision and the conclusion. Alright, so that's how it's going to be. So you can see that since F calculated is greater than what? The F calculated, please. I made a mistake there. It's supposed to be, the F critical is supposed to be 4.56, not say 6. So since the F calculated is 4.66, which is greater than the F critical, we reject the null hypothesis and conclude that there is difference in the what? In the means. Because in the treatment where we use the mean to represent, and conclude that there is difference in the means. There is difference in the means. So here too, you can say that since F calculated is less than the F critical, we fail to reject the null hypothesis and conclude that there is no difference in the, not means, but rather alphas. Because we use alpha to represent that one. Alright, so our last one is going to be the ANOVA table. See you. Alright, so that's going to be our ANOVA table. That was going to be ANOVA table. Beautiful. So yeah, sum of square treatment, put the value there. Sum of square block, put the value there. Sum of square error, like that. Sum of square of the mean, put the value there. Sum of square of the block, put the value there. That's how it's going to be. The degree of freedom, here is the K minus 1, here is the R minus 1, and here is the K minus 1, R minus 1. Alright, so that's all you're going to get for that. And this is the total. So here you can total it. I hope you can see that I'm tired. So you total it That is going to, okay, so the F calculated, that for the treatment is this, and that for the block is this. Beautiful. See you for, that is Latin, and the next one will be Greco-Latin. You will have it. See you in the next video.